Hello, welcome to Pre-Cal Lecture 2.3b, where we're going to be working problems involving mixtures. And we are still in the linear equation word problem section. And we're just going to be working these three problems on this one pre-printed note page. All right, our first one is Julie is mixing orange juice. She adds water to the concentrate until she has 2 liters of juice, which is 60% concentrate. She then adds some leftover juice, which is 75% concentrate. If the result is 65% concentrated juice, how many liters of the stronger mix did she add? All right, what we want to do is make a table here. So let's call our first column concentrate. So that's going to be a percent. All right, so we'll call our second column the volume. All right, in liters. All right. And then the third column, and you can name these something different. The name's really not part of getting the right answer so much. Is we're just going to call it pure juice. I can't think of a better name for it. Maybe you can. All right, but that is also, it's going to be in liters. So concentrate, we're starting out with a 60% concentrate. And we add until we have 2 liters of juice. Okay, and so the pure juice that we would have would be 60% of 2 liters. So it would be 2 times 0.6, which would be 1.2. All right, and then we're going to add to that mixture 75% concentrate. And we want to know how much of that are we going to add. The pure juice then would be x times 0.75. So that's 0.75x. We end up with 65% concentrate in the end. Now, how many liters of that would we have? I'm going to get rid of this L here. All right, so we have it as liters, so 2x. The total is going to be 2 plus x, right? We start with 2, we add x, so we're going to have 2 plus x. So our pure juice would be 65% times 2 plus x. All right, so that is going to be 1.3 if we distribute 1.3 plus 0.65x. All right. So we are trying to find x here. So I've got, what I'm going to be doing is adding these two, right? That plus that equals that. All right, so we've got 1.2, which would be this amount, plus 0.75x. And you could have just, we could have done all that down here, but we made it kind of wide there. Plus 0.75x is equal to 1.3 plus 0.65x. All right, let's subtract 1.2 from each side. All right, so that's going to be 0.75x is equal to 0.1 plus 0.65x. So I'm not showing each algebraic step because, this is pre-cal. You should be good at algebra. So subtract 1.2 from each side. That just leaves that there. And now I'm going to subtract 0.65 from each side, or move that 0.65 over here, making it negative. So it'd have 0.1x is equal to 0.1. So if we divide both sides by 0.1, x would be 1 liter. All right, so we added 1 liter of 75% concentrate, and you end up with a mixture of 3 liters total of 65% concentrate. All right. So let's do the middle one on the page. So that's going to be Bobby has a bag containing 2 sizes of marbles. The big ones weigh 10 grams and the small ones weigh 2 grams. If there are 5 times as many small ones as big ones and the bag weighs 300 grams, how many big marbles does he have? All right. Well, we're just going to make a chart here. Let's go with the amount as a column, and we will be doing the big marbles, the small marbles, and then we have a mix of the marbles. All right, so we've got an amount, the weight, for each marble. So not the total, but the weight for each. And then finally, we would have the total weight, which we know the total weight is 300 grams. So I'm going to write it like that, total weight. Okay, so we want to know how many big marbles there are, so it's best to make x that amount that we're trying to solve for. But we know that we have 5 times as many small marbles. All right, the weight of each big marble is 10 grams. All right, and then the weight of each small marble is 2 grams. So the total weight of the big marbles would be 10 times x. The total weight of the small marbles will be 2 times 5x, which would also be 10x. And then we know that has to add up to a total of 300, and the total weight is grams, so 300 grams. So pretty easy math equation. I would have 10x plus 10x is equal to 300. Okay, 10x here plus 10x here is equal to 300. So I would have 20x is equal to 300. So x is equal to 300 over 20, which is going to be 15 marbles. All right, not too bad at all. So let's give it one more go. The third problem, and I know this will be hard to see on the screen, but you should have the pre-printed page in front of you. So it says, a large coin jar contains 369 coins, which are a mixture of pennies, nickels, dimes, and quarters. There are 3 times as many pennies as dimes, 2.5 times as many quarters as dimes. If the change in the jar is worth 38.23, how many dimes are there? Okay, so let's just start making a chart. All right, so we've got a type of coin. So we've got a penny, a nickel, a dime, and a quarter. Now, we've got $38.23. So we know we're going to have something add up to 38.23, but the number is what we're really trying to solve for, and specifically the number of dimes. So I'm going to put X right there for number of dimes. And then we know that we have 2.5 times as many quarters. So that would be 2.5x. We have 3 times as many pennies, 3x. And it doesn't say anything about the nickels. But we do know that we have a total of 369 coins. So the number of nickels is going to be 369 minus 3x minus x minus 2.5x. So that's 369 minus 6.5x. Again, I'm just adding up all the other x's. 3x plus x would be 4, plus 2.5x would be 6.5x. All right, so it's 369 minus the number of pennies, dimes, and quarters in terms of x. Okay, so now we need to know the dollar value. And this is what's going to add up to 38.23. All right, so a penny is worth 0.01, right? 1 cent times 3x. So that's going to be 3 times 0.01 or 0.03x. A nickel would be 0.05, and we're going to multiply that by 369 minus 6.5x. All right, 0.05 times 369 is 1845, 18.45. And then 0.05 times 6.5 would be minus 0.325x. All right, a dime is worth 10 cents, so 0.10 times x. So that's pretty easy, 0.1x. And then a quarter would be 0.25 times 2.5x. So I'm doing 0.25 times 2.5x. And that's going to give us 0.625x. All of that has to add up to $38.23. Okay, so now we've got a linear equation, 0.03x plus 18.45 minus 0.325x plus 0.1x plus 0.625x is equal to 38.23. All right, I hope you can read that all the way to the corner of the board. I should have started a little further to the left. All right, so if we add up all on the left side, the constants, we would have 18.45. And if we add up 0.03 minus 0.325 plus 0.1 plus 0.625, we would have 0.43x. So that's the left side combining like terms, and that is equal to 38.23. So if I subtract 18.45 from each side, we'd have 0.43x is equal to 19.78. So x is equal to 19.78 divided by 0.43. And we would have 46 dimes. Now, could you check that? You actually could just put 46 in for x. 3 times 46, 369 minus 6.5 times 46. And then 46. Add all those numbers together, 2.5 times 46, and it should add up to 369. You could also check it, you've just done this. It'd be best to check it in the number column. But yeah, that does it. It's pretty cool to put these together. The homework is worksheet 2.3b. All right, so hopefully this was a good lecture to help you work these homework problems, and I'll talk to you on the next one.